So what we're going to see is timer on and timer off. So we will make two programs, yeah? And that should give you an idea of what is the difference between the two, okay? So I'm going to go ahead and get me a rung, okay? And then I'm going to get a timer. So timer is right here. We're going to first look at timer on, yeah? And then we are going to say this is T4 colon 0. Okay, T4 colon 0. We're going to say count for 5. Let's make it 50, so it is 5 seconds. Yeah. And this guy would be I colon 1 slash 0. All right. And let's connect an output to it, yeah? Let's connect an output to this guy. Um, so we got an output. I'm going to say O colon, say O colon 2 slash 0. And T4 colon 0 slash enable and T4 colon 0 slash done. Yeah. So that's the program right there. And we're going to do download to PLC. Go online right here. And then we go simulator, IO simulator. And this is I colon 1 slash 0, yeah? So we're going to close this guy. Let me say run. And you guys see, oh, that is 5. So that was already, that is so quick, yeah? We could not see that. So let's change that to 50. Sorry, it did not get changed to 50. Say PGM, change it to 50. Let's download it. And we're online. Here we go. Let's close this switch again. And you guys see this guy is on right away, yes? And after 5 seconds, he is done, yeah? So let's change this timer on delay with timer off and see what is the difference between the two, okay? So I'm going to go ahead and now remove this guy and let's put their timer off. And we're going to say T4 colon 0. And again, yep. Let's download it again. Go online. And watch what happened. What do you guys see for this timer off? What do you see the difference? The output is off, but do you guys see the DN? Watch, okay? Let's go online. Let's try this. Okay. Now, do you guys see that the T4 colon 0 slash done, that is, the minute it starts, that done bit is 1. So if that is 1, what's going to be this guy? This is going to 1. So the output is off, yeah? Now what we do, let's go offline and do this. You guys will see what's going on here. Let's change it to this, yeah? So download. And the output is on, yeah? Now watch. Do you guys see that? However, Uh, let's demonstrate it in different way, okay, to make more sense. Let me remove this energize. This will make it very clear, okay? This should make it clear, the difference. So download the PLC and let's go online, go here, and if you close this switch, and then what we do, see this is on, yeah? And now if we release the switch, see what happens. Still on, isn't it? Yeah? Switch is open, but your light is still on. Does it make sense or no? Let's check our other one. Let me change this to, if I can. Let me go offline. And if I can change it here. No, I can't. Oh, gosh, timer on. So timer on delay, yeah? Let's close this guy, and it is counting, and when it is done counting, then the light is going to turn on, yeah? You guys see the difference or no? And timer off, what you guys saw is it turned on right away, but when we turn off the switch, it was still on for the time we specified. Let's look at it one more time, yeah? To make it solid, yeah? So go offline, we're gonna change this to timer off. And right here, this is again T4:0. That's good. And you know, the minute this program is online, the output is on. Yeah, that's very important. And this output is going to go up. Watch this. It's going to go off after 50 seconds. Time off delay. Does it make sense? So if you look at the theory right here now, and we will look at a few programs. Now these right here are mechanical relays that you guys would see it in the industry. You guys would see it, these things also in your home, probably in dishwasher and washing machines, and you know they are used in the industry quite a bit. So those are mechanical, but we can have a PLC program which can do the same job, yeah? If you want to turn on something, turn off something, yeah? We want to delay it or we want to start it right away. So that could be done by the PLC, yeah? Now, look at this. This is the operating coil right here, yeah? And there is some mechanical linkages here, a mechanism here through which this can get closed and open, guys, okay? Let me see, enable editing. You see, this is not different than we talked about contactor. You guys remember? And contactor, what we had? We had a spring, yeah? And associated with this spring, we have normally open and normally closed contacts, yes? So when the spring is actuated, normally open is closed, normally closed is open, yes? Now similarly, this relay, it is used on a smaller voltage, and contactor, we were using it on a larger voltage, yeah? And then, so right here, it says the operating coil. When this coil is energized, what's going to happen to this coil? This contact, it's going to close, yes? And this is going to open. Sounds good? Now we have normally open terminal and normally closed terminal. They are right here. See? This is normally open and this is normally closed. And the representation, so if I use, again, you know, that is that idea I told you guys. If I use, this is normally open, yeah? If I use this contact, right, this is open and this is what? This is closed. So 0 and 1 will give me an energized output, yes? But if I use this guy and this guy, then it will give me what? Then it will give me off, yeah? Because it's 0 and 0. See, the instantaneous contact change state as soon as the timer coil is powered, yes? It's pretty straightforward. The second you turn on the switch, the contacts will get closed. The magnetic, the inductor is energized, it creates a magnetic field, and that magnetic field is closed, you know, will close this guy, and that would be it. Now the delayed contacts change state at the, what? At the end of time delay, yeah? So we see if our timer on, what do we see? It waited for 50 seconds, yeah? Or for 5 seconds, and then after that, what happened? The output was on, yes? What we just did on the PLC, yeah? On so that was time delayed, yeah? That contact waited for some time, yeah? Now, if the other one was the timer off, and that was on right away, but when we remove the switch, when we turn off the switch, it waited for a certain time, okay? So these are these normally open and normally closed. These contacts, they are designed in such a way that they would wait for their time and then they would open or close, yeah? Depending on what kind they are. So we got on delay, yeah? Provides time delay when the relay coil is energized. Look at this is the symbol, yeah? And this delay things are there in the, I can show you guys, we have there in the cabinet, okay? So I can show you some real stuff. So normally open, time, close, contact. What is it? Contact is open when relay coil is de-energized. When relay is energized, there is a time delay in closing. Does that make sense? Or no, guys? If it is normally closed, time, open contact, yeah? Then what is it? Contact is closed when relay coil is de-energized. So the relay coil is de-energized, but the contact is closed. When relay is energized, there is a time delay in opening. Yeah? Are you guys getting it? See the first one. We got a normally open. This guy is normally open, yeah? Contact is open. This guy stays open when relay coil is de-energized. Okay, relay coil, this is the relay coil. When we de-energize him, this contact is open, yeah? When relay is energized, when we energize him, there is a time delay in closing. We have to wait for a little while and then it gets closed, yeah? Sounds good? What is this guy? This guy is saying that contact is closed. Well, it is closed when relay coil is de-energized. When relay coil is in a de-energized state, this contact is closed. Yes? When relay is energized, there is a time delay in opening. And this we saw that, yeah. Let me see if we can make. Let's see. Let's go back to the. Let's use. Say go offline and okay, go online. There we go, and let's close this. So we opened that and look at that. It is still, you guys see that? You see when we, so this is time off delay, yeah? So let's make, I think you guys got the idea, yeah? So this guy right here, which is normally open, yeah? When relay is energized, there is a time delay in closing. Relay mean the relay mean this right here, the inductor, yeah, the coil. When he is energized, this guy takes a little while before it closes. That's what it is saying. The second one, the normally closed one, when relay is energized, there is a time delay in opening. Yeah, this is normally closed, but it takes him some time to open. Everybody getting it, or do you guys have a question? Getting it? Yeah? Relay symbol used for off delay timed contacts. See, this would be like the timer off. The other one was timer on. Okay? So, all right, so for timer off, what it says, provide delay when the relay coil is de-energized, okay? Relay coil is this guy, when he is de-energized and we have a contact like this, see what happens, okay? It says contact is normally open when relay coil is de-energized. Yeah, when relay coil is de-energized, this is open. When relay coil is energized, contact close instantly. Yeah, right away. When relay coil is de-energized, there is a time delay before the contacts open. So they closes, this guy close, yeah. Now there is what you did, we remove electric from this inductor, but still it takes a little while for it to open. Yeah? It's just too much of similar things, so it's hard. You have to, look at it again and again. Yeah, to make sure that you get this. Off delay symbol, so this guy, yeah? Normally closed, we see that he is normally closed. Contact is normally closed when relay coil is de-energized, yeah? If the relay coil is de-energized, this guy is what? This guy is closed. When relay coil is energized, contacts open instantly. This guy open instantly. He doesn't wait. Right away he opens, yeah? When relay coil is de-energized, there is a time delay before contact closes. Are you guys getting it? It's confusing, but what it's saying is, okay, the inductor, the relay coil is energized. Yeah, when it said is energized, and this normally closed contact is open, it's not going to get closed again right away. Rather, it's going to wait for a little while and then close. Make sense? Hopefully it does. So what I will do is I will put these PowerPoints on your canvas. Okay? So let's look at right here. Again, the on delay timer is sometimes referred to as DOE, which stands for delay on energize. When you energize it, there is after energize, there is a delay. So you guys see there is a delay, then it get energized, and then it go off. See, you close this switch, yeah? And this timer delay, this is the coil. Let's say he got energized. It wait for 10 seconds. After 10 seconds, he closes. Yeah? And after that, he will go off, yeah? See right here, this is a good representation right here. So he is off, yeah? He is off for these 10 seconds. You guys see that? And after 10 seconds, he get on. This is those 10 seconds, and then he go off, yeah? Sounds good? And if you have a normally closed one now, okay? If you have a normally closed. So, when this switch is closed, yeah, when S1 is cold, TD coil is energized, this will energize, but TD1 contacts are delayed from opening. You guys see that? This will wait 10 seconds, then it will open. Sounds good? After 10 seconds, time delay period is elapsed, TD1 contacts open, and L1 switch is off. You guys getting it? Time delay of timer. So when S1 is closed, TD coil is energized, this coil is energized, yeah? So the magnetic field is produced there. And TD1 contacts close instantly. See, this guy will close instantly when this is energized. When S1 is open, when you open this TD coil, this will de-energize. The timing start, and after 10 seconds, the contacts open to switch the light off. Gosh, you say this is hard, yeah? Huh? Yeah. Let's look at let's look at it practically one more time, okay? Let's look at it practically. You see, let's start from timer on, okay? Let's start from timer on. So let me cut this guy, and you guys will get it. I know there is too much on and off and this and that, but let's see. We're gonna say. So watch carefully, okay? Watch carefully. So we're gonna put timer on, and we're gonna do we're going to say T4:0 slash, no, not slash, T4:0, 5 seconds, yeah? And first we are going to use a normally open, okay? So let's say normally open, yeah? So this is, you can say this is timer on delay, okay? So that is the first one, timer on delay. See what happens. There we go. It waited for how long? For 5 seconds. And then your output is on, yes? Now, and when we remove the thing, it instantly turned off, yes? Now let's use normally close. Let's go offline. And now we're going to use normally close. And PLC, go online, and if you see what's going on, it is on the minute we have, yeah? So, you know, and the reason it is on is this done bit is 0 and this bit is 1, yes? Are you everybody getting it, or you guys can't hear me here? So, what happens when I close this? It is still waiting for 5 seconds before it closes. Make sense? Now, if you guys don't have the Logix Pro, this one, you know, I'm not sure. I think it's like 20 bucks or 25 bucks. If you guys want it, then you can have it for 6 months. Um, just give me a second, guys. All right, so let's now change this timer on to this was on delay, yeah. So let's take now off delay, yeah. Let's go offline, and we're gonna make this off delay. And if you still don't understand, we got an equipment, we can do it. Okay, we can wire the circuit, which you guys are going to do it. So we are going to wire the circuit and see it offline. And I said, let's put timer off, yeah? So we're going to do timer off. And first we're going to choose examine it open and analyze how this thing works. So let's make this 50 seconds and download it. And T4:0. Okay, so now pay attention, okay? When we close the switch, instantly, do you guys see on timer off, instantly this doesn't become 1, yeah? Instantly it is on. And when we open this, it will stay on for 5 seconds and then it should go off. Yeah? So this is the second delay. You see, this is right here is the PLC program which is doing it. And what we have mechanical relays which will do the same thing, okay? And you can choose time on it. So you can do it with mechanical relays, or you can do it with a PLC. You see what I mean? So let's now change this. This normally close. So this normally open. Let's close it with the instruction. And the timer is what kind? It is timer off, yeah? Download it and go online. And if you guys see, close, open. Now wait, okay? Let's start from the beginning when that is done. That is a given, see? This is closed, yeah? You see the output is closed and even the switch is open. So let's close the switch. And when the switch is closed, the output is instantly off. Let's say D40/done. Because this is 1. So if this is 1 and this is 1, this has to be off, yes? So if we remove this, now it's going to count to 50 seconds and this becomes 0. Sorry, this goes off and this is 1 and the output is on. So what I'm saying is it instantly go off. When you close it, instantly go off, yeah? It is off, but when you remove the electric or the switch, when you turn off the switch, it will wait again for how long? It will wait for 5 seconds and then your output is going to be on, yeah? There we go. So let's move on. So that's what we talked about right there. What do you guys think about this one? When I close the switch, and this is timer on delay, yeah? Uh, the T4 colon 0 slash enable is the minute, the second I close this, is this should be on or off? What do you guys think? Michael? When I close this, is this going to be on or off? Mike? On, very good. Because this turns right away. This bit become 1. So this is 1 and this is 0. The output, excellent. This is going to be on, yeah? Let's not worried about this one yet. How about this guy? When this is closed, is right away, is this going to be on or off, this output? It's going to be off, and it's going to turn on when? After 10 seconds. Awesome. Very good. Yeah? So, right here it says hardwired relay circuit motor start. 5 seconds after start button is activated. Yeah? So, when we click on start button, what's going to happen? This is going to get energized. Yeah? When this is energized, what is going to happen here? This is going to get closed. Yeah? But how long this guy is going to take? It's going to take 5 seconds, and after 5 seconds, this is going to close. And then it will stay closed, yeah? Because we would have a path this way. Are you guys getting it or no? Yes? And this is the PLC program. So we got a stop, start right here. This internal relay is maintained. Then this internal relay, and then we got the timer, and then we got this guy. We haven't talked about internal relay. We can use B3, okay, which you guys will see as we go on. But we can use this guy, and we can do it, you know, if you guys want. Let's make this guy. Let's make this guy quick. So the way they are doing it is, let's go offline, and we take this out, and let's say bit and user. So we are going to say right here, I'm going to get this guy. And let's use I:1/1. Got the output. We're going to say B:3/0. Is 0, and then what we're going to use? We're going to use this B3, and I'm sure you guys are going to say you haven't talked about B3, yeah? The B, so we will talk about it, and that is an internal bit. We can, you know, internal relay, which is called, and we can use that to turn on things, although it doesn't exist. You know, it's not like a switch or something, yeah? But we can use it, you know, an internal bit to turn it on and off, yeah, and do something for us. So, yeah, so I can use this guy. Let me see, B3:3/0. So what we are saying is when he is energized, then the timer is going to start, yeah? And what was that timer? Was timer on? I don't know, was it? I think it was timer on, wasn't it? And that was T4 colon 0, yeah? And that guy, yeah? So, oops, we don't want that. Let's put it here, this output. And let's get a user then right here. What is it? T4 colon 0 slash done. Yeah, just a way of just making more things, you know. Honestly, it's so we just want this this is the motor, yeah, this motor to stay on after 5 seconds. We got this guy. Let's close. Let's make this normally close. Let's make this normally open push button, guys. And if we click this, there we go, it start counting, yeah? And this motor is on now, yeah? It's gonna stay on. Unless what we do, we click on this. There we go. Does it make sense? Or probably not. You see, the first, that is a what? A seal-in circuit. The first one is a seal-in circuit, isn't it? Like we said before, and you guys have practice on it in the lab, that is a seal-in circuit. And so what we do, we energize. When we click this, we energize. You see, when we push this button, this is energized, yeah? Now it's waiting for 5 seconds, this is on. Now the motor is running. If you want to turn off the motor, all we need to do is press this guy once and this latching circuit is going to get unlatched. This seal-in circuit is going to get broke. So, sorry, right here. Yep, that's good. So let me turn off the recording and you guys can ask questions. Question.